Okay, so today we'll be going over the first most important concept in calculus, and this is known as a derivative. And before we get into derivatives, we first got to talk about what a slope is. So we know that the slope is the instantaneous rate of change. And you were probably given these two questions or these two equations to figure out the slope. So you know the slope is equal to y2 minus y1 over x2 minus x1, or delta y over delta x. And this is a way you could figure out slope. So let's just say you have two coordinates here. So you have right here, let's just say you have x1 comma y1, and let's just say like right here you have x2 comma y2, and you can figure out the slope of these, right? So right here you have x1, and then right here you have x2, right here you have y1, and right here you have y2. And so essentially the distance you have from here to here between the two x's is your delta x, and your distance you have from here to here is your delta y. And that's what you use to calculate slope. And this is the most common method for figuring out slope. So let's just do a quick example of figuring out the slope. So we want to find the slope of this equation, f of x equals 2x plus 1. So let's just say we just choose two random x numbers. So let's just say our x1 is equal to 1 and our x2 is equal to 3. So when we plug that in, that means we get a y1 of 2 times 1 plus 1, which is just 3. And then our y2 is 2 times 3 plus 1, which is 7. So to find the slope, it's y2 minus y1 over x2 minus x1. So that equals y2 minus y1, 7 minus 3 over 3 minus 1, which equals 4 over 2, or just 2. And as you probably know, in these equations, the number before the x is the slope, and we've just proved that. So here's another method to figuring out the slope. It's pretty much the same thing, it's just some of the notation's a little bit different. And this is known as function notation. And it's really this one we want to focus on for calculating derivative, just because it allows us to set up the equation that we'll be able to use earlier. So, you know, the same thing. Let's just say we want to do these two coordinates. Let's just say we want to do this coordinate, and let's do the same one as we did here in that coordinate. So we know the coordinate of this first number is just going to be x, or the x coordinate of this coordinate is just x. But this one is x plus a certain distance between these two. We'll just call this h. So this x coordinate is going to be x plus h. And the same thing for here. If you want to figure out the y coordinate, we just do f of x, right? Because that's all the y coordinate is. So this is just f of x. And then if we want to figure out this y coordinate of this point, we know that we said this one is x plus h, so it's the same thing, f of x plus h. Now this is going to be really important, the fact that we write it like this. So we know that our first x coordinate, our x1 is equal to x, and our x2 is equal to x plus some certain amount of distance h, so x plus h. And now we know our y1 is just equal to f of x, and our y2 is equal to f of x plus h. And so if we do the same thing, we know the slope is equal to delta y over delta x. We can say that is equal, so our y2 is f of x plus h minus our y1, which is just f of x, so minus f of x, divided by our x2 is x plus h minus x1, which is just x. So this just simplifies to f of x plus h minus f of x over x plus h minus x is just h. So this is the important equation we have to know here. And this is the one we'll be using later on. So if we want to do another example, let's just say we want to do this one, but using the function notation. So we just have f of x is equal to 2x plus 1. We could just say our x1 is just equal, let's just use this same number 1. And our x2 is, let's just say, 3. And the distance between these two numbers, the h, is going to be equal to 2. And then for this one, our y1 is just simply f of x, so just f of 1, which is just equal to 3. And our y2 is equal to f of x plus h, so that's equal to f of 1 plus 2, which is equal to 7. So now we can figure out the slope, which is again f of x plus h minus f of x over h. So we could just say that is equal to 7 minus 3 over 3 minus 1. And for that, we just get 2. And this is the same thing here. It's just the notation is a little bit different. And it's more important. So this is the equation that we have to remember and the one we will be using later. So that brings us to our next point. So the whole point of a derivative essentially is to tell us the slope at any point. And as we did earlier, those lines were linear, so the slope is always constant. It's just a straight line. But now in this case, we can use this to figure out the slope of any point along the curved line. But first, it's important to know what it means for something to be tangent. So let's just say you probably know with a circle, a tangent point is any point that is perpendicular to the center. So that's what it means to be tangent. Tangent is a line perpendicular to a point. All right, so let's just say we have some graph right here. So here's my x and y axis. Let's just say we have some line that looks like that. Okay. And let's just figure out what the slope is at that point. So this is just some coordinate x. And the tangent to this point is going to look something like that. And we'll figure out how to figure out the slope of this blue line right here. That's what it means for a tangent to a point. That's what it was going to look like. So the derivative is what tells us the slope of this line is, which is the slope at that point. So we know from before that the slope is equal to f of x plus h minus f of x all divided by h, right? And so as hopefully you've watched the previous videos regarding limits, the slope at any point we can figure out is going to be equal to the limit as h approaches 0 of this, of f of x plus h minus f of x over h. So this is the star equation to figuring out the slope at any point. So here we have a graph right here. And let's just say we want to figure out the slope at this point. Now this is just some coordinate x, right? And let's just say we have another point up here. And this just has another coordinate x. The distance between these two is going to be h, right? So this coordinate is x plus h. And let's just say we draw a line between the two. I want to use a ruler because I believe in this part it's important to be as precise as possible. So just a quick line. We draw a line between those 2 points, okay? And I'm just going to write a h down here. It's just important. And now let's just do another x coordinate along this line, but this time a little bit closer to this x. So let's just say we have this coordinate right here. So again, this is going to be x plus h, and you see this one is right there. And now it's important to notice that the h between of this blue coordinate versus this green coordinate, the h is smaller, as you can see here. So h in this case is less than. So I'm just using the colors to denote which coordinates I'm using. And again, we're going to draw a line through these 2 points. And that's what it'll look like. So now we're going to do this again, getting closer to this original x coordinate. And let's just do it down here. So again, we're going to have x plus some h. And as you can see, this h is smaller than this blue one, is smaller than this green one. So this is h. And right here. So as you can see, the h between the 2 x coordinates are getting smaller and smaller. This green h is larger than this blue one is larger than this red one. But what happens when the h equals 0? And this comes back to where we use the limit. So the tangent to x is when h approaches 0. Hence the limit as h approaches 0. Now I have an animation here that I believe can explain this a little bit better. Okay, in this little animation right here, you can see that you have 2 points being connected through a line. Your first point has a coordinate of x, and the second point has a coordinate of x plus some distance h. And as you notice, as the h gets smaller and smaller, the line connecting those 2 points begins to form an actual line. And eventually, when h becomes 0, there is that line. And that's where the limit comes in, because you're calculating when the limit of h equals 0. And so eventually, you'll be left with the line right there. And hopefully, this GIF can really show you guys how finding the limit of the distance between 2 points can show you what the slope of that line is at that point. Okay, now I just wanted to review what a derivative is and just go over it from top to bottom. I know the slope part could be like a little bit confusing, but I feel like it's important to get over the basis and the general understanding. So the derivative. So basically this equation right here tells us the slope at any point. When we solve that equation, it'll produce an equation known as a derivative. And a derivative produces an equation where you plug in a number for x. It'll tell you the slope at that point. Now it's important to notice, let's just say you have some sort of like cubic function here. The slope at this point, as you can see, that's going to be the slope of that line, is different than the slope of that line. Same thing here, the slope of that point is going to be different. So that's why you get an equation. The equation is going to produce varying results for each of these. All right. And now just a little bit about the notation of derivatives. The technical way to denote a derivative is the derivative of y with respect to x, right? And that's how you say it, the derivative of y with respect to x. So if you just have an equation like y equals 2x plus 3, you're finding the derivative of this equation y with respect to x. And you say x because the only variable in this is x. So you know the variable is equal to x. Right? And another way you can denote this as f prime of x. Right? And this is how most people commonly write it, f prime with this little apostrophe right here. But these are the same thing, these two. It's just this is a more common way. So if you have some function like f of x, and you solve it using this equation, you're going to get an equation called a derivative, which is the f prime of x. And that's how you say it. And that's really all there is to it. So just to recap, you just got to get in your minds that the derivative produces an equation that tells you the slope at any point. Now, I feel like this problem right here is comprehensive, that it's going to be able to bring everyone to understanding. So find a slope of f of x equals negative x squared plus 3x minus 2 at x minus 1, or x equals 1 and x equals 2. So in order to find a slope at these points, as you can see, it's not consistent, right? Because this is going to be a curvy graph. We're going to have to find the derivative. So we're going to have to find f prime of x, or dy dx. So as you know, we're going to start off with our equation, the limit as h approaches 0 of f of x plus h minus f of x divided by h. So we're going to do this. So we're going to get negative x plus h squared. I'm going to put parentheses in front of this. Plus 3x plus h minus 2 minus negative x squared plus 3x minus 2 divided by h. So we can simplify this. So we're going to get negative x squared plus 2xh plus h squared plus 3x plus 3h minus 2 plus x squared minus 3x plus 2 over h. And then we could factor in this negative, so we're just going to get negative x squared minus 2xh minus h squared plus 3x plus 3h minus 2 plus x squared minus 3x plus 2. Now this can be really tedious process for these really kind of complex equations, but don't worry, there are a few shortcuts I'll teach you later on that'll make these easier to solve. So we can see some things we can cancel out here. We have a negative x squared here and a positive one here, so we can cancel these out. We have a positive 3x and a negative 3x, so we can cancel that out. We have a negative 2 and a positive 2, we can cancel those out. So I believe all we're left with is, yeah, it's just that. So once we simplified it, we're just left with negative 2xh minus h squared plus 3h all over h. And then we could pull out an h, so this is equal to h negative 2x minus h plus 3 divided by h. These two h's cancel, so we're left with negative 2x minus h plus 3. And as you remember, we're doing the limit as h approaches 0, so you can just plug in a 0 for h, and we're just left with negative 2x minus 0 plus 3, which is just negative 2x plus 3. And there we go. Here's our f prime of x, or the derivative of negative x squared plus 3x minus 2. But we're not quite done yet. We found a derivative. So this equation will give us a slope at any point on the graph. Now we want to find it at x equals 1 and x equals 2. So the way you can write this is just f prime of 1. And we can plug that in. So for x, so negative 2 times, or here I'll write it out, negative 2 plus times 1 plus 3, which is going to be equal to 1. And then we have to find f prime of 2, which is equal to negative 2 times 2 plus 3, which is just negative 1. So these are the slopes. That one and that one. So this equation, hopefully you can see now, this equation will tell us the slope at any point on a graph. And we can solve for these. So if we're given an x, you only need the x coordinate to do this, because that's the one that really matters. So you could just plug in any x coordinate. So for 1, if we want to figure out the slope at where x equals 1 is on this graph, we just plug that into our derivative, and we're given 1. And the same thing for 2, negative 1. So there you go. And that's how you do the derivative.